This is a simple but important message here, the relationship between the change in velocity and acceleration. And the message is that delta v and a vector are in the same direction. So to illustrate that, let me take two cases. The top case where I have a motion diagram showing an object moving to the right that's slowing down. And then the lower one is the opposite case of an object moving to the right, speeding up. So you can tell this object is slowing down because the displacements to the right are getting smaller and smaller in magnitude. And so the fact that the displacements are getting smaller in magnitude means that the delta displacement is pointing to the left. So in other words, in order to get R12 is equal to R01 plus delta R, and R23 equals R12 plus delta R. So numerically 3 minus 1 equals 2. I'm bookkeeping the right direction as positive and the left direction as negative. 2 minus 1 is, 3 minus 1 is 2. 4 minus 1 is 3. 3 minus 1 is 2. 2 minus 1 is 1. But if delta R is pointing to the left, that means that delta V is also pointing to the left. And delta V is pointing in the same direction as A, because A is equal to delta V over delta T. And for this upper case here, the direction for V is always pointing to the right. And so the conclusion is if delta V and A, which are pointing in the same direction, are anti-parallel to V, pointing in opposite directions, then you have a situation where one is slowing down. You can see that from the sketches that I've made here. Delta V and delta A are anti-parallel to V. They're pointing in the opposite direction. Now the lower case shows the opposite situation where you have an object moving to the right. But this object apparently is speeding up because the displacements are getting larger. Displacements to the right are getting increasingly larger. So in this case, the delta R is to the right. The delta V is in that same direction to the right. Delta V and delta and A are in the same direction, both pointing to the right, and V is also pointing to the right. And so we have a situation of speed up where delta V and delta A are parallel to V. So the question I would pose here to you is there are two other cases that I haven't sketched here, and those would correspond to the object moving to the left instead of to the right. To the left and speeding up, and to the left and slowing down. And I would like you to just take a piece of paper out and make an analogous sketch of motion diagram delta R, delta V, A, and V for both of those, and see that the same thing happens if the object is moving to the left. In other words, slowdown will occur if delta V and A are anti-parallel to V, and speed up will occur if delta V and A are parallel to V.